Hello, Kirtana, I'm audible. Kirtana, please let me know first whether I'm audible or not.
Yes, sir.
All right, Kirtana. So, yeah, in the last class, we discussed about some thermal effects of electric right? Share, Kirtana, I have shared my board. Please let me know what is your situation.
Yes, sir.
Okay, Kirtana, do we had a discussion about power consumed by group of resistors? I think we had. All right, Kirtana. So I'm just going
Power
to give you
consumed
another
by
problem.
lamp with it.
Uh, Oh, I think lamp we did in the last class, right? One problem I gave about the lamp. Two lamps were there.
Yes, sir.
Okay, Kirtana. So let's go further, and I'll be giving you one more topic. Like this chapter is not that much. This topic is not that big. Okay, 5 to 6 problems we'll do, and this completed it. So this is basically a resistor in the battery. This is 5. So Kirtana, this is the structure. Basically, circuit is given to you. Okay, find power supplied by the 10-volt battery. And thermal dissipation and thermal power dissipation in 10 ohm resistors. Okay, now, so this is the problem for you. Uh, Time given for this one will be 3 minutes, just 3 minutes, not more than that. Time starts now, you can just start screen. Change it. Okay, so that's the time, 3 minutes. To solve it, let me answer. We'll move to the next page. Okay, if you solved it, please let me know first. And last 1 minute is left, so we have less time to solve.
Done, sir.
Alright, we are done with the time answer. Okay, so Ketna, just get me the answer.
Power supplied by 10 volts is 20.
Okay,
And
power applied.
thermal power is
Sorry.
40.
Okay, thermal power is 40 and wait, thermal power. Okay, what is the first one? What is the answer for the first part?
20, sir.
Okay, and what for the second part?
40, sir.
Okay, um, okay. This was actually 10. I will do the complete data. So this is 5 volt. This is 5 amps basically. You had to get what is the from here and from here. Right? Okay. How you can calculate this one? If I ask you like what is the way you don't know that what is the power supplied by this person. So one way is if you anyhow you can get to know that what is the current going in this branch. You will get to know that across this some current is going and in this way I can get it right. Okay.
Sir, I can't see that.
Okay. So Kirtana, how did you get answer like how did you get 40 for this part?
So I used I square into R.
Okay, what is the value of I you have got?
2, sir.
Two value, but makes sense. Okay, in which direction I you have got Kirtana? Like two is fine, but in which way? This way or this way? What is the direction of current?
So
Alright,
from,
yeah, let's say I'm making two ways. Okay, this is burst
sir, I
or
can't see the diagram.
wait. I'm using red pen. Like this is first way, okay, and this is second way. So which way you have got I?
Sir, I can't see.
Hello, Kirtana, are you there?
Yes, sir.
Yeah, okay. Like two ways are there, current I and current I. So which way you have got current I in this circuit?
Like from 10 volts to 5 resistance.
Okay, fine. Kirtana, what is the current you have got across this branch? Look, Kirtana, like this is one branch, okay? This is another branch, right? So which method you wanted to go with, KCL or KVL? It's up to you. Like whatever method you want, we will try to solve on that method.
Previous.
KVL, right?
Yes, sir.
So, okay, let's go with KVL. So we have three nodes, maybe one, two. Okay, we have four nodes, right? So which node you want to take as 0, which node you want to take as x, a, b, c. Now you can point out. It's up to you. Whichever node you want, we will take that as 0, and whichever node you want to make a variable, we will take that as a variable. Okay, guys, now let's do one thing. Let's take this node as 0, and let this take as x, okay? So what's the way? I know one thing that I am 0. I'm going from here to the lower to just add it up. This point is 20, okay? Alright. This node is x. What about this node? I know Kirtana, let's say here it is y, right? I went from y, then plus 10, that comes out as x. It means y plus 10 is equals to x. So what is y? Y I can simply call it as x minus 10. Okay? So what is this node? This node is nothing but x equals to 10 minus x. So what I was supposed to do? If I ask you apply KCL or KVL, right? So can I really apply it? Anyways, can I apply this? The answer is no. Okay, let's do it. What is the current in this circuit? Let's say this is I1. What is the current in this circuit? This that is I2. And what about this one? Do we have idea about this current? I'll say no. I really don't have any idea. So what I can simply do is minus x by 10 plus this minus this, right? So 10 minus x minus 10, that comes out as 10 by 5 plus the rest, whatever I'm going to left with, that is going to be the current in this circuit, okay, the last. So let's call this as I3 is equals to 0. So what I have got, x is minus x by 10 plus 10 by 5 is equals to 0. This is one thing I have got. Okay. Yeah, that's fine actually. Let's look for it. Okay, this is I2. And let's do the same process in at this particular node, okay, at this particular node. So what it will be, we'll say so that here it is 20, 20 minus this thing, 20 minus 10 minus 6, okay, that will come out as 10 plus x, basically it will become 10 plus x, 10 plus of x, okay, divided by 5 plus, again, x minus this and minus, so it will come out as 2x minus 10 divided by 5 mm, plus I2. Okay, so this is what I am going to do. And by convention, I have assumed that current is going in this with I3, so here I'll call it as minus. It is supposed to be 0. So here now, if you see carefully, what I'm going to get is 5, 5, 10 plus x plus, sorry, here that is fine itself, 2x minus 10 minus 5 I3, 0, 3x minus 20 minus 5 times of I3 is equal to 0. If you just resolve this circuit, what you are supposed to do? This is 10, maybe 2 into 2, so it will become 10 times of I3 minus x plus 20 is equal to 0. So you can call it as x is equal to, I really don't want x. If I get I3, that is more than enough for me, okay? So maybe what I'm going to get x is equal to 10 times of I3 plus 20. Maybe I can substitute this thing over here. So 30 times of I3 plus 60 minus 20 minus 15 I3 is equals to 0. So okay, now to see carefully what is it? Wait, not this part. Yeah, this part basically. So what is this part coming out to be? Um, what I can see that is maybe 40 minus 13 is 15 times of I3 is, so I3 is coming out to be 40 by 15. Kirtana, is it clear in the whole way what we have been done telling?
Yes, sir.
Okay. Didn't you find any error till you? Kirtana, didn't you find any error till you? Hello, Kirtana, didn't you find any
No,
error over here? Oh, there was an error. So this will not work. The reason is for that thing, like whatever the case KVL, sorry, I applied KCL in this one. Okay. The method which I went through till now, that was KCL, and you told me to apply KVL. Okay. So this was the biggest error we can get. Okay. That's what I was thinking why you're not saying this word. I used to know this should be messy. What is the main crux of the KVL, Kirtana? What we do in case of KVL? Kirtana, Kirtana, what we do in case of KVL?
we take loops, sir.
Yeah, so when in the last quiz, why didn't you bother to tell me, sir, this is KCL, not KVL? Okay. Look, so in loop, it's up to you whatever you want to do. So let's say this as one loop. Okay. I1. Let's call this as an I1. In this loop, which way you want to take current? In this way or this way?
The
Okay,
first one,
let's take
sir.
this one, right? Okay. So let's say this loop is I2. Okay. Alright. So let's go in the first loop. Let's say this part. Let's start from okay. Let's go from here. Okay, and I'm going in this way. I'll come back to this position. This is what I want to do. So you can see the equation. First, I'm going from here to here. Okay, then I'll go from here to here. Then from here to here. Then from here to here. Got it? This is one loop I'm going to complete. So the first is 20 because I went from here to here. Okay, so this is 20. Okay, if you see it now here, my current is going this way, and I am going this way. So what I have to, what I'm supposed to add, I'll be saying I'm going to add it. Okay, then I'm here. I don't have anything else current is. I'll just put the battery. I'm going to lower to high. So make it just as 10. Now I'm here. Okay. I'm going from here to here. Again, it's saying see at this part current is in this direction. So I'm going opposite to the current. I'll have to add it. I1 times of 10. So okay, now this is one thing I've got. You can say this 15 times of I1 plus 30 is equals to 0. I1 is equals to minus. Got it? Okay, now look at this statement if you are using this.
Yes, sir.
Okay, so I'll just erase it and mark all the circles. Okay. So I had this kind of current, right? What does this mean that? That from here the current I1 is going. Okay, but if you see my I1 is having a negative direction, mean to say I assumed this way, but the real direction is this. Can I say this quick enough?
Yes, sir.
Because it is a negative. Okay, let's not. Okay, now come up to I2. If you see I2, I don't have too much thing. I'll start from here, go to here, then here to here. Okay. So even I can simply say, uh, what is it? Okay, 10. Then I'm going from here to here, right? I'm going in the direction of current. So that will come out as a minus times of I2 times of 5. So you can see that now I2 is equals to 4, 2 amperes. Okay. So basically, this is correct direction, right? So can I now mark all the possible direction which I have got for the current? I can say Kirtana, I1 was this way. In this way, I can say my current is going this way with 2 amperes. Can I say this Kirtana?
Yes, sir.
So basically, this current is going, but okay. And from here also, I'm getting 2 amperes. So can I say Kirtana, the both currents are going to go into this way? with 4 ampere.
Yes, sir.
Okay. So what I have to calculate? I have to calculate power due to this one. So what is the power? I square. What is I? 2 square into 10. So 40 watt. Across which? Across 10 ohms. 10 ohms. Okay. What is power across 10 volt? So I think voltage I have, I just need to get to resistance because I don't have any resistance across. So here I can simply say what is the current passing through this 10 volt? Can I say that is 4 ampere? That makes up to 4. Okay, so the answer for both of them is 40. So you have got this thing is correct as 20 because I know what mistake you did. You might have taken I1 as this is, so you assume that this is 10, this will be 20. But if you see carefully, there are two currents. Right? This is also going in this branch, this is also going in this branch. Although this would have been cancelled out if this is the real direction, but real direction which I figured out is this way, right? That's why both are going same direction, so that they get added. Clear it now?
Yes.
Any doubt?
No, sir.
No. So I'm giving you another problem to solve this little answer. Wait, let me just make this also right. Okay, good. So in this problem, you have to calculate power supplied by each battery. Okay, power supplied by each battery. So what does this mean, Pika? If n battery is there, and if current, the net current going through this in this is this way, means the current is going from this. This is supplied. This if it is going inside it, it means this is a case of absorbed. Okay, so you have to get the supplied or absorbed. Both cases are there. So yeah, this is the problem. It means solve this statement also. Okay, let's make a time for 5 minutes. Okay, I'll give you 5 minutes for this. Although it's an easy part of it. Okay, now there's 1 minute left, so we will solve it within the same time. Okay, now we are done with the time. So, hello, Kirtana, have you got the answer for this one?
No, sir, still solving.
Okay, let's solve this one. Okay, Kirtana, I don't know why is it- Look, Kirtana, the question says, get me the power supplied and absorbed. So I can simply say that if I get to know what is the current across this, either this way, either this way, I'll just get it. From here also, if I just wanted to current, or here also, I just wanted to current going across this, right? So I can simply say that because if it is about the resistance, so if about the resistance, either you will get voltage, either you get current, you can calculate it. In case of voltage, like cells, I need current, right? So my main task is to compute the current. So generally, what happens is, Kirtana, always look at the very center. How many nodes are present? One junction, other junction, another junction, another junction. Right? So if I say, Kirtana, what I have already told you, you have to take one junction as a zero. So maybe I can take this as a zero. Okay, this is solution. Red pen is the solution. This is the zero. Assume this to be the x. If Kirtan, now you can say that just by two ways, I have covered all of the nodes, right? Because I know this is x. Okay. Uh, so and this is zero. So I can simply say because here to here if you go, right? Basically, you can say the whole thing is zero, right? Potential difference is 10. So you are going from lower to higher. So you will just add this part. So it was 0 plus 10. This is 10, right? The whole thing is 10. Mean to say this point in 10, right? No. It will be 10 in the complete. All the wires, this whole wire is having a 10 potential. So till here it is 10, right? If this is 10 case, now you will go from here, add it, because you are going to lower to high. So you will add. It will become 20. This is 20. Okay. The whole node is 10. This is also 10. Basically, this whole wire is itself 10. Okay. This is 0. It means till here it is 0. Okay. What about this part? This is x. So you are going from here to here. So it will become x plus 30. Is
Okay.
that clear? No?
Yes, sir.
Any doubts, please look at the figure and just. Okay, Kirtana, can you now solve it? Can you get the current value in all the respective branches?
Yes, sir.
Okay, this is a hint, Kirtana. So I'll this time I don't think you need 5 minutes, right? Okay, I'm giving you 2 minutes, Kirtana, to solve it with this hint. Kirtan, now you have got the answer.
Yes, sir.
Okay, what is it?
The power in 15 volts is 45.
Across 50 it is 45. Okay.
In 30, it is 162, sir. In 10 volts, it's 53.
In 10 volt it is 53, right?
57.
Okay. 50. Okay. Kirtan, what is the current you have got across each of them?
3 amperes, 5.4, and 5.7.
Five. Kirtan, no, no, like answer is incorrect. Okay. Let's go. Kirtan, at which junction you wanted me to calculate the things? Okay, Kirtan, what you have taken this value?
I I did it for with KVS.
Okay, fine. You did it with the KVL value. So, why- okay, when I gave you already all the junctions, so why did you went with the KVL?
Like I was
You could have
solving the from the start.
okay, you solved it from the start, right? All right, I'll just go with the KCL, right? Let's take whichever node you want. I'll take that. Any specific node, Kirtana, which you want to take, or I can take any node.
Anything.
And so let's say I'm taking this central node, right? It can connect a lot of things at the same time. Okay. So, yeah, Kirtana, which node I can simply go with? Let's not take this node because it does not have all registers at the same time. I don't know which I can take. To alright, Kirtana. So basically you are here. Okay. So can I see Kirtana at this point which currents are coming? If you see carefully from here, I'll say let's say this is one direction current is going. this is one current is going, this is another current is going, right? If you see about this current, it has two directions. So I will say that from here you are having two different currents going. One is this way, one is this way. Okay? So instead of considering this, I will consider these two ways. This is what I am going to a basic idea. So for this one, I can simply say kitna x by 0 by 5. Okay? Plus for this way, like this is the current. So x minus this point is 10. Right? So this will x minus 10 by 10 plus. For this point, kitna, I know this is x plus 10, right? So I'll simply say x plus 10 minus 25. That will be x plus 5 by 5. X plus 30 minus this one. That is 10 itself, right? So you can simply keep it as x plus 30 by. The whole thing is, if you see only one variable is there, please solve it. The moment you solve it out, you'll be getting x equals to 5. Voltage. So it will be volt. 5 volt. This is what my answer will be. Okay. This is just a potential. Now I can remove all points. This is okay. So now I have got this value as how much? Minus 5. This junction is minus 5. Okay. So I think now I can solve all the points, right? Can I do it? Yes, I can. So what is the current? Like potential, I had here it is x plus 30. I assume my current is going in this way. So what is the current in that way? Let's say Kirtan, this is I. This is I2. Whatever the current it is going. So what is I1? I1 I took it as x plus 30 minus 25. So that is minus 5 plus 30 minus 25. So if you see, if you just add all them, what I'm supposed to get Kirtan, that is C. Maybe divided by 5. So you can say the whole thing is 0. Right? So this means this value of current is 0. It means I don't have any current in this branch. Okay. I don't have any current in this branch. So this current is 0. Done, Kirtana? Is
Yes.
that clear? So what is the power across 15? V into I, that is 0.
Zero.
But V has value, but I is. Let's talk about this. I have this. This will give me the current of this circuit. So that is supposed to be around. So if you just do this, how much you are going to get? X plus 30 minus 0 is the 5. So this part is clear. X value you already know minus 5. So let's call this as I2. Minus 5 plus 30 by 10, 2.5. It means you have a current is equals to this much. So this current is how much? 2.5. Okay. This is how much it is left. Okay. And what's the next part? Anything else is left with now? Okay. I have only calculated for the 2 months and yet to calculate the two part. Okay. Yeah. Okay. Um, it should not be the complete one. How much is current coming out of this place? That is minus 5 minus 10. Right. Let's call this as I3. This one. So I3 came out as minus 5 by how much is that? 5x minus 1. It means I have got minus 1. That means that I have made this direction to be in this direction, but ideally I3 is in this way. I1 current is going this way. 1 ampere is going this way. 2.5 ampere is coming out to be this way. So Kirtana, 25, like these two branches, three branches are there. I am getting 2.5 current here. Okay. This way, 1 ampere is going. So how much is this way? That is 1.5. Can I say this, Kirtana? I don't even have to calculate the rest part. 1.5. So what is the answer, Kirtana? Power across this 10 volt. How much is that voltage
16.
into 1.5? 50. Okay. What about this one, the 30th, right? What is the current across this? So you can say that, Kirtana, This is branch. Here I am getting zero current. Here my current is how much? Uh, I think 2.5. Okay. And in this way, how much I am getting from this branch basically. Let's say some current is I. How much is this I? I know this is going this way, zero is going this way. And in this particular branch, how much current is coming out to be? Two ways are there, right? Because here you can see this one is going, right? But one here it is zero, so it means whole one is getting inside. Okay. This one. So what is it? Two. That 1.5 was less. So this whole 2.5 is going inside. Right? From here it is 1, here it is 1.5. So how much is the current? 2.5, right? So P of 10, 30
Mhm.
is equals to 2.5 into 30, 75. Okay, this is the answer. Got it?
Yes, sir.
Kirtana, any doubts?
No, s-
Okay, no doubt, right? Kirtana? So I think I can end the session by this. I just have a next class after this, so yeah, I'll end it up here. Yeah, goodbye, Kirtana. That's all for the today's class.